Okay, so I don't regret not doing a video in the future. I'm going to do a video now. I'm not going to say I've gotten some grief over it, but yeah, that definitely wouldn't be the right word, but I get questions about that speaker box right there all the time. Just had some recent ones, and I don't mind answering questions about it. You know, like I often say, the only dumb question is the unasked question. So I built that. Of course, did make a video. Figured it's a speaker box. What could anybody possibly need to know about a speaker box? Well, I get a lot of questions about it. So the project I'm working on is down on the bench. So I'll really quick go over the speaker box, since I do get a lot of questions about that, either on YouTube or people just emailing me. It was a old, God, what the hell was it? I think it was a deviation meter originally. I don't even remember who in the hell made it. But I'm one of those people, I dismantling stuff all the time, parting out stuff, and I never get rid of anything. Especially boxes. Especially from test equipment, because they're usually extremely nice heavy-duty boxes. So I had this nice empty box. Now the faceplate that's actually behind this had, actually I think that was a meter hole. I didn't, one hole I didn't have to drill. And actually the rectangular hole where this fit was, I think, a big switch originally, and this connection block here fit perfectly into that hole. But I had to drill a bunch of other holes. But the blue was actually I think that was the top cover off of a really old, it was either a sweep generator or just a signal generator. But in any case, that was, something parted out of something else. I just cut out a panel to stick in here, drilled all the holes. Now what I actually have here is, it was set up so I can hook up, I don't need big gigantic stereo speakers a lot of times when I'm working on stuff. I'm not, at the time I'm not checking for fidelity. If I want to check for fidelity, I'll use better speakers. I just need something I can put some audio in and I can hear left, right, front, rear is actually working. Especially when working on automotive radios, which is specifically what I designed this for. Because if you'll notice, there's actually, sitting on top of it, there's actually rubber feet. So this isn't attached to anything. I can just take this down, set it on the bench. I can actually set a automotive radio then on top of it, on top of these little rubber feet, and work on it. But, so I can put speakers in through these little spring-loaded jacks. I have these banana plugs down here that I can go through. Actually, these are multi-purpose too, because these things are actually spring-loaded. Those push back. You can stick wires in through the little side terminals there. But there's, each set, so, red, black goes to that one, these two go to this speaker, these two to this speaker, these two to this speaker. Same thing with these. Red and black, top left go to there, bottom left corner, they go over here, these two to that one, these two to this one. And then the same thing with these BNC jacks. This one to that one, this one down, it's pretty straightforward. Now the switches, what the switches are for, I actually put 4 resistors inside, 4 50-watt resistors, for dummy loads. So in case I want to run 4 speakers, but I don't want to be listening to it, I can just put all switches down. Now I wouldn't hear anything, but there would still be a load on the, whatever it was I had hooked up to it, because I have it hooked up to internal high-power resistors on the inside. I had this little jumper set up, so like when you're working on automotive radios, they usually use a lot of them will use a common ground for all the speakers. So with this little jumper cable I made up, it's just 4 BNC jacks, all just daisy chained together, so I can short all of the grounds together, but they still have, holes in the back, so I can still hook up grounds. If I need more or less resistance, I can, like in this case here, I can run speakers in series or parallel by pairing them up, like I say, in either series or parallel. So I have a bunch of little jumpers made up. Now the BNC jacks weren't put in there to put audio in. What I have those in there for, that way I can run if I have 4 channels going into this, I can run 4 BNC cables down to my 4-channel oscilloscope, and I can view all 4 audio waveforms at the same time. So, brief description, that's what the little box is. Oh, and the speakers, if I remember right, I think all 4 of those came out of iHomes. There's actually a little tube behind them about that long. Little rectangular tubes. It actually has the baffles in it. They were the little, internal speaker boxes for them to have the whole, the port in the back. I was actually able to, this cabinet was deep enough, I was actually able to incorporate those into this box. So these speakers aren't just hanging out into nothingness inside the cabinet. They're actually in their own little, you know, acoustically designed speaker baffle boxes on the inside. So what am I working on today? So the current project is a connection box for being able to hook up pretty much any, I guess you could say, any audio source to any radio. Now, this box, again, it's a recovered or recycled box. You'll notice there's some funny little holes there and a bunch of rectangular holes down here at the bottom. That used to be the front. This was a switch panel box for a strobe light bar on a tow truck originally. I changed out a strobe light bar, put on a new one for a friend who owns a towing company, and this was the old switch box. It was an old cheap junk Chinese light bar, you know, wasn't worth the shit, but nice little aluminum box. And of course, I don't throw anything away, so I kept the box. Took all the switches out, took out the little LED indicator lights. There was another little board in here that had indicator lights. And then, this being an audio box, I don't want RF energy to get in here, so I didn't want all those open holes. So I just tacked on a piece of, you know, metal on the back to basically re-enclose the cabinet. You know, has the cover here. You know, you can see it was meant for installation because it already has mounting threaded holes on the sides for the mounting bracket, which I also have. So that's what the box was. Now, what spurred this, you know, me to make this was a while ago I got a huge assortment. Actually, let me show them to you. For those of you that, I think I actually did a video showing them and actually asking some questions if anybody had wiring on them. But they're microphone adapter plugs. Oh, this little box is heavy. So, back in the heyday of CB, when everybody had one, when CB was the basically the cell phone of the day, and back in the day, everybody had different microphone wiring. Unlike today, they're fairly standardized. There's a few different ones, but for the most part, there's only a couple. Back then, and over a large, you know, several decades, there have been dozens and dozens and dozens and dozens. I mean, a room full of people doesn't have enough fingers and toes to count all the possible microphone wiring, you know, combinations and different types of plugs. So these are made by a company called Mura, M-U-R-A. Actually, one of my bench microphones is a Mura. That's right there. They made good microphones. Now, I got these, but the problem was I didn't know what the wiring was for these. So I had absolutely no idea what they fit. Now, all of the ones you're looking at here are different. Absolutely none of these are the same. They're all wired completely differently. So, you know, and even these 4 pins, that's absolutely nowhere close to all the possibilities of how you could wire 4-pin mic plugs. But, you know, they're all numbered. You know, like there's A1, you know, A2, and A3 and so on. But, and then the inputs on these, they're a 5-pin DIN 30-degree lock ring, which is what that is. So if you're familiar with trams, like a D201, they use the 4-pin with the 30-degree lock ring. So they also made 5 pins, but that's what the inputs are on these. So I've switched over already most of my bench microphones to use this. That way I can use these adapter plugs with anything. Nice thing is, there's lots of the old ones, which I work on a lot of old radios, so plugs are kind of hard to come by today. So, you know, there's the standard 4-pin, there's your standard 5-pin DINs, like those of you familiar with, like, Realistics, or, you know, some of the Cobras use these. There's also a bunch of 6-pin DINs. There's more DIN plugs, but these are the, you know, the reverse. These have the female pins instead of the male pins. There's old 3-pin styles. There's 1/4-inch phone jack styles. There's the old antique 4-pin style. There's, like I say, the 4-pin DIN 30-degree lock ring. There's the 5-pin DIN 30-degree lock ring. There's the 6-pin, which is still the same 6-pin mic plugs like they use today. Here's some other oddball ones. That's a 5-pin DIN style. But the nice thing is, I have dozens and dozens of extras. So, because there are some missing. I can just obviously see from the numbering system that there are some skipped. But that's no problem, because I have a lot of extras of every single type. I can make them up as I go. If I find one that I don't have, I can just wire up a plug for it, and I've kind of been putting this off because I knew it would take a while, and it did. But I dismantled every single plug you see here and traced out the wiring on it, and now have a wiring chart for all of these plugs. So, I now know how all of these are wired. So, now that I have them wired, I want to be able to use them, and I can get rid of a lot of the other adapters I've been using over the years, and, something I really wanted to make a good interface box. I have an interface box now, but I really wanted a good one. Well, now's the time to do it. And like I say, with these plugs, I can add modern plugs to this assortment as well, because this kit, or back then they didn't have the 5-pin plugs like we use today on a lot of radios. So plugs like this, they apparently didn't have those. So fortunately, these 4-pin plugs internally, where this part actually mounts inside this housing here, is smaller around than our modern plugs. These are a little bit bigger. So the nice thing about this is I can take a new 5-pin or 6 or 8-pin inserts as well. So even for like some of the 8-pin plugs, I can take one of those new inserts, turn the back side down, just chuck this in a lathe. It only needs to be turned down about a 32nd of an inch. It's a small amount, but I can't quite get these into these housings without reducing their diameter a little bit. But like I say, just chuck it in a lathe, reduce it about a 32nd of an inch in diameter. They fit right in and they mount perfectly, which is exactly what I did to this one. This was one that I actually turned down. So now I was able to make this, and this one, it's my custom number on there now. And I think this one was a 5-pin Cobra, is what this one is. I'd have to look it up on my chart. But like I say, so I can make new ones because I have so many extras. Works out really nice. But like I say, I want to use these. So, get this back out of the way. And boy, those little critters are, that box weighs several pounds, because those things are thick, heavy die-cast metal. So, what I have here is, because I work on radio, so I need to be able to not only just hook up a microphone, I need to be able to hook up audio sources to a radio, so I can modulate it with either a 1 kilohertz tone or double tone if I'm doing doing sideband alignment and whatnot. Never know, I might want to test out different microphones with different radios. So I wanted to make a all possibilities box, I guess you could call it, so I can hook up anything to anything, and that's what is in the works right here. So from a technician's standpoint, most of the time it's impossible for me to use my hands for, when I'm keying a microphone. It's really hard for me to, a lot of times, just to do this. Years ago, I've started using foot switches because I got tired of trying to put microphones between my leg to squeeze it, because a lot of times I need to be able to hold a test probe on something inside on a circuit and, adjust something, a meter, be varying a voltage or a signal source going into that radio. So I need both of my hands. So I started using foot switches. Let me reach down here under the bench. I can grab one of them. So just these little foot switches. They're industrial foot switches, but they have a 3-wire switch inside, so you can have a receive and transmit switching. And then I just have stereo 1/4-inch phone plugs hooked up to them. So I have the shield as the common, the ring is receive, and then the tip is transmit. It's the way I have mine wired. But so inside this little box, I've already started doing some of the wiring on it. Here's the inside of it. But this plug plugs into this bottom jack, so this is for my switching circuit. So that way I can use this little guy to key the radio. And I have 4-pin and 5-pin. Now I stuck this 5-pin DIN 30-degree lock ring on here because this is the style that I'm going to be, I'm switching most of my microphones over to. So if I want to hook a microphone directly up to this box, I can hook that up right here. You never know, it's easier to put stuff in now in the beginning stages, so I've added both male and female 3-pin XLR plugs. Here's a 1/4-inch stereo input jack. Here's RCA input. There's 2 BNCs. Now, actually, there's 2 BNCs for the simple reason that if I hook up an audio generator to this, that let's say does not have a built-in voltmeter, just has a potentiometer or the attenuator, so you can change the level, but it doesn't actually have a meter to tell you what the output voltage is. That way I can hook up that audio source to one BNC jack, hook up to this other BNC jack with a cable up to this leader millivolt meter right here, which accurately measures from 5 Hertz to 1 megahertz. So then I can actually monitor, because a lot of times when you're doing a transceiver alignment, they might tell you something like audio input at 20 millivolts, 1000 Hertz. So that way I can hook up that meter directly to the box down here. There's also 2 1/8-inch jacks. There's a mono and a stereo. Now, of course, most radios, they're going to be mono to start with, but in case I'd have a jack, like I could hook an iPod up to it. That way, if I want to have some complex modulation, not just an audio tone, because sometimes it actually is hard to diagnose something with a single, continuous, non-changing tone. So I could hook up an iPod to this jack. Of course, that's going to be stereo, but I only need one wire off of that. So, I just pick the left channel. So, but that way, like I say, I have a choice. I can do mono or stereo jacks. Now the switches. This switch here, now being able to hook up microphones or this little foot switch, you have to remember there's a receive and a transmit wire in most of your, especially modern radios. So, let me get the camera back here a little bit. So, what you want to avoid doing is if I have this plug for this switch plugged in right here, and at the same time I might have a microphone plugged in here. Well, the microphone also has a push-to-talk button switch in it as well. And if I were to, say, step on this, that's trying to put the radio in into transmit, while the push-to-talk button switch inside the microphone is trying to tell the radio to stay in receive. So the poor radio is not going to know what the hell to do. So it's trying to transmit and receive at the same time. So to eliminate that, what I've done is I've installed this switch, and it's a big, it's actually, it's a mini switch, but it's actually a very large switch. You can see it actually has 4 sets of switch contacts in there. So, their terminals are 3 deep and 4 wide. But what that switch allows me to do is I can select either the foot switch, or if I flip it, then I can select that the microphone will control the actual push to talk. This doesn't have anything to do with the audio. This is just what is the control source for my switching, either the foot switch in the down position or the microphones in the other position. Now, another problem. There's 4-pin and 5-pin. Most of your modern radios have the common on the switching, the switch that switches the radio into transmit or receive inside the microphone, that one's tied to ground in most radios. In most old radios, they didn't. You did not need a microphone plugged into the radio for receive, because if you ever notice a lot of radios, unless you have the microphone plugged in, you can't even hear the received audio out of the speaker. Most of your old radios aren't like that. What they had was a shield, an audio, and 2 push-to-talk contacts. So you were actually grounding or supplying voltage to a relay inside the radio, the actual switching relay. So, but I wanted to have a 4-pin. So like I say, I'm trying to switch everything over to this 5-pin, which is why the 5 pins are nice, because that way you can have an audio, shield, transmit, receive, and the common for those transmit-receive switch on that 5th pin. 4 pins, you can't do that. There's not enough pins. So like I say, that's why most of your modern radios with 4 pins, you'll see that there's usually 2 wires will go to the one that has the shield on it. There'll be the shield and another wire. That's tying that common switching contact to ground. Well, with this switch, and I made this what I call an idiot-proof switch, so I can't accidentally bump it. So this is a pull switch. Okay, so I need to pull out to be able to switch it. So I can't just accidentally hit it. I have to physically grab it, pull out on the switch to be able to flip it back and forth. But what that does is, so in this position, that ties because this one here is wired for like Cobra, Galaxy, all your most of your modern radios. So they use pin 1 as ground or shield. So with the switch in this position, that ties the shield to the common switch contact on the push-to-talk, the actual push-to-talk switch. When I flip it like this, it disconnects the common from the ground. So then basically that would be this jack where they're separated. So that way I can use either 4-pin or the 5-pin style, and like I say, all in one box. So like I say, I'm actually pretty far along. There's actually not a lot left to do on this, but I got to call it quits. I got customers' radios to work on. I can only spend so much time on stuff like this. That's the only thing sucks about when you're working on other people's stuff for a living. You have very, very little time to ever do anything for yourself. So, like I say, I got a few more things to do. Now, the actual outputs on this, I'm just going to have 2 cables. I'll have 2 7-conductor microphone cables will come out of this box, and they'll have one of them will be a standard 4-pin, and then the other one will be this 5-pin DIN with a 30-degree lock ring, so I can use all of those Mira mic adapters that you saw. So, like I say, it's coming along pretty good. I got all the switching circuits pretty much already wired down in there. I got the terminal tie strip here just to make things a little bit easier for interconnecting stuff. And then over here on the other side, that's where the actual microphone cables, the outputs, will hook up to. I haven't hooked up the XLRs yet. I still have those to wire in. Everything in here is good, high-quality stuff. With the exception of the 2 switches, all of the jacks, everything is Switchcraft. These are the XLRs are Switchcraft. All of these jacks are Switch. Although actually not the BNCs; those are Kings. But the 1/8 inch, the 1/4 inch, the RCA, both those microphone plugs, and this 1/4 inch stereo jack down here, they're all Switchcraft. I don't like using junk stuff. Just doesn't hold up. That's a good, actually the terminal strip's CK, and then actually both of these switches are both C and K. So all good high quality components. No need to cheap out. Like I say, I recycled a box, so I saved some money there. But there's, like I say, that's pretty far along right there. This'll make working on stuff a lot easier for me, because it gives me a lot more options for connecting stuff. And different microphones. I can leave different things hooked up, at different times. So I can leave a microphone plugged in and still have an audio coming in here or from somewhere else. I can leave multiple things hooked up. One of the things that actually what will be hooked up to this is actually going to be a paging microphone. I have to swing the microphone around here. It's actually a gooseneck mic. This is old Turner Telex. It's actually a paging microphone. Now this has a push-to-talk switch. So if you were to walk into a restaurant, they have that little stand that I don't even know what the heck you call the guy. I can't remember off the top of my head. The guy that greets you when you walk into a fancy restaurant, and calls you to your table. Well, they might have a microphone. Or if you're at a podium, up on stage talking to people. This is that kind. This is a paging microphone. It's Turner. It's a good, really high-quality mic. They sound really good. Have a really ultra-flat frequency response. Now, I don't use this switch. I use another foot switch. That's another thing. I can get rid of some of these blasted foot switches I got on the floor, because I don't have enough feet for all the damn switches I got. But the reason I have this is, like I said, most of the time I'm using both of my hands working on a radio, so can't hold a microphone. So, that way it allows me to, I'll leave this microphone probably permanently hooked up to this box. That'll allow me to just, when I need it, I can just swing it down. I can be talking into it, key the microphone with the foot switch, and I never have to take my hands off what I'm doing. And, I don't even have to take my eyes off of it. I can just, like I say, once this is flipped down, all I need to do is find the switch on the floor with my foot and talk into the microphone while I'm, looking at an oscilloscope and probing and adjusting inside of a radio or whatnot. So, if that gives anybody any ideas, hey, have at it, make your own. Get yourself a little project box and a handful of jacks and switches and have at it. Like I say, I thought I'd actually do a video on this one, so I could at least, I don't know if I'll show a second video showing it completed or not. I might, whenever I get back onto this thing. But like I say, I've received so many questions on that speaker box. Before I forgot, I thought I better do a damn video on this because I can just hear it now. Man, what are all those jacks for? How do you have it wired? What's it do? So to try and save myself from having to answer 500 emails and comments on YouTube, I figure I'd actually show what it is, explain it, and at least show some of what I got on the inside. Now, one thing I might need to do, and I won't know, I'm not going to add any bypass caps to this yet. I might need to. Now, it's in a metal box for a reason, so RF energy can't creep into this thing. That's why I put this piece of metal on the back to close up all of these holes, because I don't want RF energy leaching into this box and then leaching into my audio line. So I'll 100% complete this, have it put together, the cover on, and I'll try it. On standard radios, it won't be a problem, but when I'm working on amateur radios, 100 or 200 watt rigs, there might be a possibility of some RF energy leaching into this. So I'll see. If I do have any type of feedback problems or anything, then I can add some bypass caps. It'll be really easy to just come in here, right here, just add couple ceramic caps straight from the audio, straight over, because these are the ground, the common, it's a solid wire that runs all down, all around in here, to everything. I can just add a little bit of bypass caps in there, just in case I do have any type of RF feedback problems. But I'm hoping I don't, so that's why I'm not going to bother sticking them in there. So there you go. There's just a quickie view of some of Mike's Mad Scientist project.